In our next unit, we're going to be looking at writing equations of lines, and we're starting off with something called function notation. First of all, a function is a relationship between two variables where each input is paired with one output. I know that definition may not make a ton of sense, so I have a visual here. Today we're going to be working with function notation, which is this f of x notation that you see here. What that means is x is the input. You drop it into the function if you're looking at this visual here. Our input is our x values. So just like we saw with graphing lines, we had an x value that we could put into the function, and then we would get some y value out of the function. F of x is simply replacing y in the equation. It just means what's coming out of the function for an answer. So you can see if we drop x into this function, and the function says add 4 to your x value, when x is 2, we add that 4 to it and we get 6 for our output. So that would be represented by f of x. Hopefully after we run through an example, this will make a little bit more sense too. Our essential question today is, what is function notation and how does it work? Hopefully after a few examples, you'll understand a little bit better about what function notation is. Starting off with a function that is 3x minus 1, and we're given these different x values. So we're going to put the x values into the function. So notice we're replacing x over here with -2. So I am also going to replace x on the other side of the equal sign with -2. You can kind of think about this like the golden rule. And then we do the math. 3 times -2 is -6, and -6 minus 1 is -7. Now we're told to express our answers as a table and a set of ordered pairs. I'm going to start with ordered pairs, and once we have all of our ordered pairs, we'll put it in a table. Our input, or our x value, was -2, and our output, or our y, or our f of x, was -7. The next value we're asked to evaluate is 0, so I'm going to replace x with 0 everywhere that I see it in the equation. 3 times 0 is 0, and 0 minus 1 is -1. So my ordered pair would be my x value is 0, and I got a result, or an f of x value, of -1. And the last value I was asked to evaluate was 1, replacing x with 1 on both sides of the equal sign. We get 3 times 1 is 3, minus 1 is 2. So my ordered pair, I put an x value in of 1, and I got an output of 2. To express it as a table, you simply make an x f of x t-chart instead of an x y t-chart, and you list those ordered pairs under the correct column. Our first ordered pair was -2, -7. Our second ordered pair is 0, -1. And our third ordered pair is 1, 2. So that's how we express it as a table. And the last thing we were asked to do was talk about domain and range. Domain is what you put into a function. It's any x values that make the function what's called defined. Looking back at our original equation, when we put an x value in, we will multiply it by 3, and then we will subtract 1 from it. So we think about what numbers can we multiply by 3, and the answer is all of them. What numbers can we subtract 1 from, and again, all of them. So our domain is all real numbers. This is a symbol. I'll draw it a little bit more slowly if you didn't catch that. I make 2 lines, and then I just make an R around them. That's an all real numbers symbol. It means any number is okay to put into this function. Range is what we get out of the function. When you look at this function, it's a line. We get all numbers out of a line. So again, we have all real numbers for our range. Next, we have a square root function. We're going to start by trying to evaluate the function at -9, replacing x on both sides of the equal sign with a -9. The square root of -9. Remember, a square root gives us an answer that when we multiply it by itself, we get back what we started with. So what number can we multiply by itself to get -9? It doesn't work. If we take 3 times 3, we get +9. If we take -3 times -3, we also get +9. There's no number that when we multiply it by itself, will give us a negative value. So this one is undefined. And we can't write that as an ordered pair, so we'll take a look at our next one. We have f of 1. The square root of 1 is 1, plus 8 is 9. So we get the ordered pair 1, 9. I put x into the function, and I got 9 out of the function. Our next value is 4. We're going to replace x with 4 on both sides of the equal sign. The square root of 4 is 2. 2 plus 8 gives us 10. So to write my ordered pair, I put 4 into the function, and I got 10 out of the function. And we were asked to evaluate the function at 16, replacing x with 16 on both sides of the equal sign. The square root of 16 is 4. 4 plus 8 gives me 12. Writing that as an ordered pair, I put 16 into the function, and I got 12 out of the function. Setting up my table, I have my x and my f of x values. The first ordered pair I got was 1, 9. The second ordered pair was 4, 10. And the third one was 16, 12. Domain and range on this one are a little bit trickier. We saw from that first example that we can't take the square root of a negative. So let's think about the smallest value that we can take the square root of, and that is 0. So our domain is any x values that are greater than or equal to 0, because we can't take the square root of a negative. Our range is a little bit tricky as well. That's what we get out of the function. So let's think about putting this 0 into the function. When we take the square root of 0, we get 0, and then we add 8 to it. So our f of x value, our smallest f of x value, was 8. So our range would be f of x is greater than or equal to 8. And as you can see from our t-chart over here, all of our f of x values are bigger than 8. Here's a you-try question for you. Substitute those values in. The domain and range on this one is a little bit tricky as well. If you at least get your ordered pairs in your tables, we can talk about domain and range together as a class.